Then they put two ferromagnetic contacts on top of them. Now, as we know from what I told you earlier, when we pass an electric current through the ferromagnetic layer into the normal metal, we inject the spin current, right? We get this non-equilibrium spin accumulation in this normal layer. Now, the electric current that we put into the normal layer will follow whatever voltage gradient you apply to your material. So if you drain out all the electric current here on the left-hand side, that's where all the charge current is going. Now the spins that you inject, on the other hand, they will follow whatever spin gradient, whatever magnetization gradient you have in the non-magnetic material. And so if you're far away from the injection point, let's say you're at this end or at that end of the wire, the spins actually relax, and there's no magnetization, no spin accumulation far away from the injection point. And so what you end up with is you have a spin current going to the left and also to the right. And so here on the right-hand side of the device, you end up with a pure spin current and no charge current associated with it. So one way how you can think of it is, let's say you have a spin down electron here that you inject, and it travels here, flips its spin, and travels back. Or as I said earlier, you can have two opposite spins moving in opposite directions.
I have a question about
Sure.
that. I don't know if I can ask it.
Absolutely.
I was thinking, if you have two spins
Yes.
that are traveling in opposite direction, you still, I mean, I figured that as two electrons that
Yeah.
are traveling and they
Yes.
still bounce with the atoms, and you have still some energy dissipation.
Yes. Well, so that is a question that occurs quite commonly. And so the one thing is, dissipation is always associated with drift currents, where you have a potential that really drives your current. Now these are diffusive currents, and diffusive currents you normally don't associate dissipation with it, but that really doesn't help answering your question all that much. So the point is, at this point I really don't know if there's any dissipation associated with it and how much it is. So for really showing that things work better than in a traditional electronic device, you have to make a real device that has the same functionality than what you compare it with and see what you get. And we are far away from doing that. Because even let's say that this part of the current has very little dissipation, you still have to generate the spin current with an electric charge current here. And so in this pumping process of generating the spin current, you also have